Video we looked at the one learning hypothesis, how the modern deep learning is built upon the analogy of how the brain functions. Basically it's about a simple algorithm that our mind follows. It can basically adapt to everything. So following that one learning algorithm, today we are going to look at the very basic thing, that is linear regression. Right, so basically machine learning is divided into three types of ML, I'd say. First of all, there is supervised ML, then there's unsupervised ML, and the third one is reinforcement learning. Let me give you a brief intro about all of these. So, what happens in supervised machine learning? Basically, it's about like you have a supervisor, like for every input X, you have output Y, and built upon that, you train your model, which is basically your ML model. And what happens, like you have this supervisor, like for every value of X, you will predict Y hat, which is your prediction, and you will cross check it with the actual prediction, that is Y. So like suppose I know that X cube is a function, so for X and Y I'll do this: 1 cube of 1 is 1, then 2, that is 8, then 3, that is 27. And then my model will predict something like, for 1 suppose it predicted 0.9, for 2 it predicted 11, and for 3 it predicted something like 26. All right, so based on this I will compare. See, our teacher gives us marks, right, in every exam. So we will have an exam between the Y hat and the Y. And based on this, we will try to minimize the gap between Y hat and Y. So this is what happens in the supervised machine learning. In unsupervised machine learning, what we have, we for every X, we try to predict the output Y regardless of knowing what the actual thing is. It is basically used for understanding patterns in data. Okay, and then there is this reinforcement learning. It is completely different from both of these. It is more like functioning of human, like from child we grow up knowing nothing, then we do hit and try things, and for every good thing we get a penalty, that is positive reward, and for every bad thing we get a negative one. Suppose you burnt your hand with fire, next time you will remember that going near to this fire is going to burn me up, so you will give it a negative mark, and never in your life you will go again near the fire. All right, so this is what happens in reinforcement learning. Basically we have an RL agent, reinforcement learning agent, and we program it like it tries to maximize its functions. All right, so this is about the types of ML. Now coming to the supervised machine learning. In supervised machine learning, I told you we have a supervisor, like for every X we have a Y, and we predict an Y hat, and then we try to minimize this Y and Y hat. All right, so in supervised learning we try to basically solve two types of problem. One of them is regression, another one is classification. Okay, so what happens in regression, we try to predict a continuous value output, and in classification we have discrete values. Now what do I mean by continuous and discrete? Suppose I'll take example of two problems. Very simple one that most people like. I have to predict house price. All right. Or let's not take this one. I mean, we can take this one, but I want something like simpler one. It's about, let's say, breast cancer prediction. Okay, okay. This might cause serious problems, I guess. So let's take about something like size of t-shirts or something. Let's go back. Let's stick back to our house prediction. Okay, house price prediction. All right, we are given with some features like I know number of rooms and I know area of the house. Okay, these are two important features on which our price of house is built. Suppose there are three rooms in a house, and then the area is like 5600. This is in square feet, all right. So let's say this cost us 1 lakh rupees. Then again, I have a house with two rooms, but these two are big rooms. So let's say this is 6600, and this cost me like around 150. And similarly, I have many rows of data, and then I try to predict based on these two features. I try to make a prediction of y hat. Like I am given with like five rooms, and the area is like 10,000 square feet. So I predicted something like, let's say, 5 lakh rupees. All right, and luckily I have an entry for this, and this cost me like 6 lakh rupees. So what I will do, I will try to minimize this difference. Okay, based on this, I will train my model. I will try to predict y hat for all of these values, and I will try to minimize this gap between values that I will predict. So this is what happens in a regression problem. Whereas for classification problem, let's take example of t-shirt size. Okay, see, different companies have different sizes for medium, XL, XXL. All right. See, these are not fixed. These are made on something like the data we collect from the customers. So I have my data of customers like this. Uh, this is suppose, let's say, size of their chest. All right. And then the data is like this. And this side would be size of t-shirt. Okay. So my data is something like this. See, as size of t-shirt, chest grows. This is size of chest, okay, and like this, okay. So what I did, I tried to find some pattern in this data, and based on that, I clustered them. Okay, I clustered them. I made saw these two are clusters, and this is the third cluster. So I made this one as medium size, this one as extra large size, and this is XXL. All right. So this is a clustering problem. So this comes in unsupervised learning. We didn't know that what output we will have, but we still try to figure out some output. Like for X, I tried to make three classes. I did not know what is the correct answer. Maybe you will make three classes like, wait, maybe some of you will make three classes like these three and these three. But I don't know. See, I cannot say that this one is wrong, but for me, the earlier one sounded more reasonable to have three sizes of t-shirts like this. Alright, so this is a clustering problem which comes in unsupervised learning. So let me take a very basic example of linear regression. See what happens in linear regression. Linear regression, okay, linear regression is type of regression problem. This is very basic algorithm of regression. See, we have an output x, output we have an input x, sorry, this is input, then this is corresponding output, and this one is the actual output, all right. And then I have an predicted output. This is what I will prediction. Okay, so what happens in linear regression? Let me make it a bit clear. Okay, I have these three things. What happens in linear regression? Suppose I have x, I have y. Okay, what I will try to find a line. Okay, I will try to find this line where, let's say, this is the, what we say, this. So this is my slope and this is the intercept. All right, so I will try to figure out a line. Let's say this line is y hat equal to mx plus c, where c is my intercept and m is my slope. Okay, I tried to find this line such that it will minimize these. This is what this is. Showed you, right? I have so two features like x1, x2, and then I had this y. Okay, and I had this y hat. This y hat I am predicting means, according to this line, I am predicting this y hat, and these are the actual outputs what I am expecting. So I will try to minimize this gap. So what I will do, I will find a line which will minimize this gap. So for this, I will need to find the distance of this point from line. Suppose this is the line, this is the point. I will try to find this line, this length of the line, and then I will try to minimize it. All right. So this is what happens in linear regression. We try to find a best fit line. Okay. We will look the nitty-gritty of this algorithm, linear regression algorithm, in the next video. But for now, I would like to try to show you some basic things that we can try. Suppose I have my x, that is going to be my input variable. So I'll see this as input. See, let's say x will be our, let me zoom it for you. Okay, x is going to be my input. So I will see if I could make x as I in range 1 to 10, means 11. So what will this mean? This will mean that my x would be something like this. Okay, see, my x is from 1 to 10. All right, what I'll do now, I'll make y similar to x, and this will be cube of x. All right, for I in range 1 to 11. All right, so this is our output, the actual output. Okay, what I did, the actual output, and then I will try to show you why. See, this is cube of the corresponding value of x. All right. So now what I will do, I'll use NumPy. See, I have imported NumPy and the linear regression model from scikit-learn. So what I'll do, I'll make my x as NumPy dot array. Sorry, NumPy is np, right? So np dot array, and then I will pass x. Okay. So what x will become something like this. Okay, it is an array of integer. But when I will look at this, okay, x dot save, what is this? This is 10 comma nothing. All right, we'll come back to this later, but right now all you need to know that this is 10 comma nothing. Then similarly I'll repeat this for y as well. So I'll copy it, paste. Now, okay, see, y is the actual outputs of these. Okay, then I have to make model. To make models, we do not have to build right now the whole model by ourselves. I'm taking help of scikit-learn. Model equal to what? Linear regression. All right, this is clear. We have instantiated a model, and now what I have to do, all I have to do is fit model dot fit. What we have to fit? We have to fit x and y. See, what is this saying? X would be our input and features and samples, and then y will be array of targets, means the output. All right, weights we are not initializing right now. So what this will do, this will give me an error. All right, I see you must have seen when I showed you this. This fit function takes input as n features and samples, but when I showed you right here, right, that shape of x shape of x was something like this. Sorry. Okay. uh, uh, when we did x dot shape, we got something like this, 10 comma this. Sorry, we got this 10 comma nothing. So see, we needed a matrix, right, where this should be m into n, but this was nothing. So what is this? This is actually nothing in NumPy. All right, when we want a 10 comma 1 means we had to think of these features, right? See, we had to think. See, we had to make n features and n samples. We had n samples. These are our training examples. Like for one, I have one output. For two, I have eight output. For three, I have 27. For four, I have 64. For five, I have 125. But I needed to provide how many features I'm using. But I was using no feature. See, this was nothing, so no feature. Do I want that? No. I want one feature. Means for one x I need to have y. So I have one feature, right? This is my feature. So for this feature, what I'll do, I'll need to see again what I'll need to do. I'll need to do just one simple thing. When I was doing this and was numpy of array x, then I had this x dot shape. It was n comma nothing. So all I had to do is copy, write a code something like this: x equal to x dot reshape, and what I have to do is pass the shape. Okay, so what is the shape? 10 comma 1, right? Done. See, that's it. Now my model will work fine. See, this is linear regression model and it fitted my x properly. Now what I have to do, if I want to predict this same, see, I have x, this is my x right now. Okay, this is my x, which is one row in, see, this is what, this is actually a row matrix. Sorry, this is a column matrix. All right, this is a column matrix. See, 10 comma 1, this is my x. See what I did, I'll show you again. I had this simple thing. I had x, for that I had y. All right, see, for 1 I had 1, for 2 I had 8, for 3 I had 27, and similarly like that for 10 I had this. Okay, this is what I was talking about. So for this I had to convert this into something like a matrix of, a matrix of what, 1 comma 10. Yeah, I had 10 features and one, sorry, 10 samples and one feature, and 10 samples. Samples is nothing but the number of training data we have, like this. These are our samples. So what it became, it became a column matrix like this. Okay, where I had 1, 2, 3, and the further processing is done inside the linear regression. We will talk about that too when we will implement that whole thing with TensorFlow or PyTorch. Okay, but right now all we have to think is what is happening in this. Okay, so we had this. Now we want to predict this y hat for the same x. So what I'll do, I have to do this model dot predict what, just x, and then I will store it in y hat. Okay, now, so what I'll do of y hat, I'll print this y hat, and I'll have y. Can you see the difference? See, I was expecting this as my output, but I am getting this as output. This is a big difference, all right? Because I have not done something to make my model better. I need more training example. I need to do a lot of things, but I have shown you that how you can build a model. It is very naive model. It is not totally to be published or do something out of that, but this is how a model is built by coding. Because if I show you everything in starting, the math behind this, the nitty-gritty behind this linear regression, you're not going to understand anything. So coding while working, that is going to help you a lot. And then let's plot this. So see, this is what's happening in our model. We have, I'll just copy this image. I don't know how to do it, but okay, I guess this is copy. Then let me see if I could paste it. Okay, perfect, fair enough. See what I'm doing. My model actually saw, see what my model did. My model had some data points like these, which are marked in red. These are the actual data points. Okay, I'll do it in red. See, these are actual data point. I'll rather say them Y. And this blue thing is what we did was Y hat. See, this line would be y hat equal to mx plus c, where this is the intercept and this is this mc. All right, and x is x. So understood the point. No, I think 0 would be somewhere, right? Okay, 0 is somewhere here, so this will be the intercept. Sorry, 0 will be somewhere right here, right? So when we'll make this line, 0 will be this. So this is the intercept C we are talking about. So, but you understand the point, right? This is the line y hat equal to mx plus c, and our model figure out that this is the only way to minimize these points. If we had more points, we could have made a better model. So one of the thing that I could use to improve the performance of this model is to make more points. Besides, these points are biased, I had no negative point in here. Like cube of negative numbers is not present here, right? See, cube of non-negative numbers is not present here. So how am I going to make a model which is, but I tried this, right? So I could do some more things like my data should not be biased. But this is what basically happens in a linear regression model. I hope you understand this video. Thank you for watching and take care.